name is Ashley Carpenter, and today we will be looking at a 5th grade science experiment on how can temperature change matter. Today, we're going to be looking at what is the effect of the temperature of the water when a balloon is filled with a yeast mixture, creating a chemical reaction on the circumference of the balloon measured in centimeters. So we have 3 containers. For our experiment, we had 3 containers, and we had ice water, where we filled up a container with ice water, and we filled up a container with room temperature water, and then we filled up a container with hot water. And we took our balloons and we used a funnel and we dropped it in to the balloon, the yeast mixture, and then we tied up the balloon, and then we just placed it into each container of water, and the results, we will see what happened. So I predict that as the water temperature increased, the size of the balloon circumference will also increase. This experiment is about chemical change and how temperature affects the rate of a chemical change when the balloon fills up with the gas created by the yeast mixture. Students may not be aware that the gas in the balloon is produced by a chemical reaction, so the amount of gas produced reflects reaction rate. The increase in circumference as the temperature rises should lead students to conclude that increased temperature results in a faster reaction. We have vocabulary terms in this science experiment. We have a chemical change, which occurs when a new substance is formed. We have circumference, which is the distance around something. We use circumference in this science experiment. We use a string to measure the circumference in centimeters around the balloons after they sat for 30 minutes in the water. We have gas, a sample of matter that conforms to the shape of a container in which it is held and acquires a uniform density inside the container. We also have matter, a physical substance, and we have yeast, single-celled fungus that ferments sugar to produce alcohol and carbon dioxide. And these were our variables. We used our manipulated variable was temperature of water. That was the only thing that changed in this experiment, is the temperature of the water. We had our bucket of hot ice, cold water. We had our bucket of room temperature water, and we had a bucket of hot water. And our responding variable was the circumference of the balloon. That was what we measured. We measured the circumference of the balloon in centimeters. And our constant was the measurement of the yeast mixture, our deflated balloon size. So we started out with, we used 30 balloons, all the same size. Containers, amount of water, and the time left in the container. And these were the materials that you needed. You needed 3 plastic tubs, ice water, room temperature water, hot water, measuring spoons, a graduated cylinder, dry yeast, sugar, string, ruler, 30 balloons, and scissors. And this is a picture of our supplies. And then we went ahead and we completed the experiment. And here are some pictures of me doing the experiment. This is right here. This is where we are putting in the yeast mixture into the balloon using a funnel. And then right here, this is where we place the balloons into the buckets of water. And this is our chart. So you can see we used, for ice water, we had 10 trials. For room temperature water, we had 10 trials. And for hot water, we had 10 trials. And then our average, we had 14 centimeters for the ice water in balloon circumference. Our average for the room temperature water was 19 centimeters, was about 19 centimeters. And then the hot temperature, the circumference of the balloon was about 25 centimeters. And then here's just a nicer chart to look at that shows the median, mode, and range. And here is a bar graph for you to look at. So as you can see, that the balloon circumference increased as the water increased. And these are some photos. This is the after results. So when the balloons came out of the ice water, they were still deflated. The room temperature water, the gas made the circumference of the balloon get larger. And then in the hot water, the balloons became fairly large, the largest. So the average circumference of the balloon sizes increased as the water increased. So in conclusion, temperature affects the rate of a chemical reaction. As the water temperature increased, the circumference of the balloon also increased. The gas in the balloon is produced by a chemical reaction. So the amount of gas produced reflects reaction rate. The increase in circumference as the temperature rises allows me to conclude that increased temperature results in a faster reaction in the yeast mixture, producing a chemical change. So, have you guys ever watched pizza dough being tossed and then baked? Bakers use yeast to make breads and even pizza dough. Even pizza dough, they create a yeast mixture. Yeast goes into the pizza dough to help it rise. And when the dough is placed in a warm oven, the chemical reaction involved speeds up in the cooking process. The chemical reaction speeds up throughout the cooking process. And also, decreased temperature slows down many practical chemical reactions. This is why we keep food in the refrigerator to keep it from spoiling. Batteries also stay fresher longer kept in the refrigerator because of the reaction slowing down in the cooler temperature. And here is a photo. Here is a photo of the yeast mixture reacting in the balloon, creating a chemical reaction. Thank you so much.